Welcome to The Explainer. Today, we're diving into a real headache for serverless developers, something we've all struggled with for years, and we're breaking down the AWS technology designed to make it a thing of the past, Lambda Snap Start.
Look, if you've ever built a serverless app, you know exactly what I'm talking about. That dreaded cold start, that pause, that frustrating lag when your function spins up for the first time. It just kills that snappy user experience you were going for.
So here's the plan. We're going to kick things off by really digging into the cold start problem itself. Then we'll see how Snap Start comes to the rescue. We'll cover what it can and can't do, I'll show you how to flip it on, and then we'll wrap up with the most important part, the best practices you've got to know to use this right.
All right, first things first. Let's really break down what we're up against. This thing we call a cold start. So what's actually happening here? Well, Lambda has to find a server, download your code package, fire up the runtime, for Java or Python, and then run any initial setup code you wrote. That whole dance can take a few seconds. And if you've got a user on the other end waiting for an API response, a few seconds feels like an eternity.
So what's the fix? Well, let's get into AWS's really clever solution, which they call Snap Start. The whole idea here is to stop doing all that work when a request comes in. Snap Start flips the script and does all that heavy lifting way ahead of time when you publish a new version of your function. This means that all that slow initialization stuff is taken completely out of the critical path when a user actually calls your function.
So here's the play-by-play. When you publish your code, Lambda runs your whole initialization process just once. Then it takes a complete snapshot, a picture, of the memory and disk state of that fully warmed up environment. It encrypts that snapshot and keeps it handy in a cache. Now, when an actual request comes in, it doesn't build anything from scratch, it just grabs that snapshot and resumes from it. It's kind of like making a perfect photocopy of a ready-to-go environment and just handing out copies on demand. And this right here really shows you the key difference. We're moving away from that whole slow boot up process that happens on the first request, and we're shifting to a super fast resume operation. All that time-consuming setup just vanishes from the user's wait time. So what's the payoff? Well, this is the whole point, right? We are talking about taking startup latency that was several painful seconds and crushing it down to well under a second. For any app that real people interact with, that's not just a small improvement, it's an absolute game changer.
Now, you might be thinking, hey, what about provisioned concurrency? And that's a great question. You've got to know the difference. Provisioned concurrency is like keeping a fleet of taxis idling with the engine on, ready to go. It gives you incredibly fast double-digit millisecond response times, but you're paying to keep them warm, even when they're not doing anything. Snap Start is the perfect solution for spiky, unpredictable traffic, giving you amazing performance without that constant cost.
Okay, so now that we get the what, let's talk about the where and how. Because, there are some pretty important rules and limitations you need to be aware of before you jump in. Okay, so first up, compatibility. This is a big one. Right now, Snap Start is only for Java, Python, and .NET runtimes. So if you're a Node.js or Ruby developer, or you're using container images, you're out of luck for now. And this is really important. It only works on published versions of your function, not that $latest tag that we all use for development. There are also some limits on storage options, so definitely check the docs on that. So where's this thing really gonna shine? Well, it's tailor-made for anything that's sensitive to latency. Think about public APIs or any service where a real person is on the other end, clicking and waiting. It's also a massive win for apps that use big frameworks with long startup times. I'm looking at you, Java world.
Okay, so the great news here is that even though this is some pretty powerful stuff under the hood, turning it on is actually super easy. So if you're in the AWS console, this is literally just a few clicks. You just go to your functions configuration, find the general settings, and under Snap Start, you pick published versions. You click Save, and you're almost done. And that last step is key. You have to publish a new version of your function. That's what actually tells Lambda, hey, go make my snapshot.
And for all you infrastructure as code fans out there, don't worry, it's just as simple. It's a single command using the AWS CLI to update the function's configuration. After you run that, just like before, you publish a new version and you are good to go.
Now, using Snap Start is simple, but the way it works, with this whole snapshot and resume thing, it introduces a new way of thinking, a critical consideration that you absolutely 100% have to think about in your code. This is the big question, the one you have to ask. If every single new environment is just a clone of that original one, what happens to stuff that's supposed to be unique? Think about a random number, or a temporary secret, or a unique ID you generated during initialization. Well, it's going to get duplicated. Every single time. And that, my friends, can seriously mess up your application. Can you imagine a bunch of different instances all trying to log with the same unique ID? Or even worse, a security token that gets reused across multiple invocations? Yeah, that's not good. You have to handle this. So, the fix is to make sure you create all that unique stuff after the environment is resumed from the snapshot, not before. The simplest way is to just do it inside your main handler code. But the best tool for the job here? It's something called runtime hooks. Runtime hooks are a special feature just for Snap Start. They give you these little windows where you can run your own code at two super important moments, right before Lambda takes the snapshot and immediately after it restores an environment from it. The before checkpoint hook is great for tidying up, closing any open network connections so they don't get frozen into the snapshot. But the after restore hook, that's the real hero for our uniqueness problem. This code runs in every new environment right after it's restored from the snapshot. It's the perfect place to reestablish fresh network connections or, more importantly, generate brand new, unique IDs and secrets just moments before your main code runs. All right, so let's boil this all down. Number 1, Snap Start is a massive performance boost, slashing those cold starts. Number 2, it worked its magic using a clever snapshot and resume system. And number 3, with that power comes some responsibility. You have to be smart about state, making absolutely sure that things like unique IDs and secrets are handled after the restore. And that kind of leaves us with one final thought. Is the cold start problem finally solved? Well, for many, many use cases, Snap Start gets us incredibly close. But it doesn't just erase the problem, it transforms it. It introduces new things to think about, like how we manage state and uniqueness. It forces us to think differently, to architect for this new reality, and really start designing for a truly fast, serverless future.